All right, so this is the most anticipated Math Society presentation of the academic year. And there's a reason this is the #1 presentation in the world, right? So let's get to it. Varad, do you want to introduce our guest to what we're presenting on today?
Absolutely. But first,
No.
before I do anything else, I want one volunteer to come up and play a game.
Oh, yeah.
Wait, hold on, ladies. One at a time. Shh. Okay, you know what? Yeah, take the seat here. Okay.
All right.
I know you've been you can take the seat down there. Okay. So I'm gonna introduce you to this game.
Guys, sorry. Let's listen to the volunteer up here, okay?
So.
Hey, no, don't worry. Not everyone here will know about the topic. Guys.
Wait, do you know how it works? Or like, we need someone that doesn't.
Yeah.
Oh, okay.
All right, guys. Sorry, can we get some? Let's listen to Arush and Varad.
You're indeed correct.
Oh, sorry. I think Sahil, do you have?
This is a good topic.
Huh?
I respect this.
Thank you.
Hey, Akshaiyan, good topic.
All right, guys. Shush. Let's start the presentation. So we're gonna start with a game called NIM, right? So Varad, do you want to walk through our guests on what the game is?
Absolutely. So for Arush here, he's in the seating.
Yeah.
We're gonna have 3 piles. Okay. Do you know how NIM works?
No.
So you have 3 piles, each with one with 3, one with 5, and one with 7 stones. Okay. You can remove stones on your turn.
So feel free to come in.
You can only remove stones from one pile, but from that one pile you can remove as many stones as you like. Okay. And then whoever takes the last stone at the end of the 3 piles wins, not loses. Okay. I'll let you start.
Everyone understand the game, the premise of the game? Okay, yeah, let's go. Let's play.
So do you have like the winning strategy on your
No. I've just got a set of techniques that will help me. But that's what we're coming to later.
Guys, we'll come to it. Let's just respect.
I'm pretty sure the second player always wins because they can like mirror my moves effectively and like always.
You can believe I can start if you want.
Sorry. I think there's someone else at the door.
I can
Feel
start
free
if
to
you
come in,
want.
Richard. Yeah, a bit of a full house, but see if you can find.
I can start if you want. Let's not try and debunk.
Okay,
the game
guys.
just yet.
Let's start. Let's play the game.
Let's play the game. I'll remove 1 stone from the 7 pile.
Yeah.
Those you can see.
Okay.
All right. Arush, what's your move gonna
I'll
be?
move 1 stone.
That's perfect.
Okay,
Right?
that's a good move. Thank you. Allow me a moment to perform my calculations.
Have you got the win now?
Not necessarily.
So essentially, what Varad is doing here is a game like this. There's no chance, right? Think of a game like this, a game like chess. Hence the chess imagery in the promotional material. Something like this, it isn't left to chance. So Varad's going to show us how we eliminate the chance.
I'm going to remove 1 stone from the 7th pile.
Let me know.
Take your time. No pressure. Okay.
Arush has removed 1 stone from the pile with 7.
Let's switch things up a bit, okay? I'm going to remove 1 stone from the 5 pile.
Arush is thinking very deep about this. For those of you near the back of mind.
I'll keep it simple for now.
Okay. He's removed 1 stone from the pile originally with 5.
Very interesting, Arush. I'm going to remove 3 stones from the 7 pile.
Varad has removed 3 stones from the pile.
So the 7 pile is now gone.
Have I won? Nag, have I won or have I lost? Nag, there are 3 stones in each pile. Have I won?
There's 2 piles left with 3 stones each.
As many as I want.
Let's just finish the game. Let's just finish the game first. Yeah.
So guys, I think I've lost the game.
For those of you watching online, Arush believes that he's lost the game.
Okay, we might need to. For the sake of time, we might need to.
Yeah, let's just get it split up, guys.
He's removed 2 stones from the 3 pile. I'm going to remove 2 stones from the 5 pile.
So now wait, just to show everyone.
There's 2
We've got
stones.
2 piles left with 1 stone each, and it is Arush's turn.
Take your
Pick
pick.
a stone.
So Nag,
Not that it will matter.
You should have worked, Nag. You should have worked backwards from the state and then I was lost.
Yeah.
Okay.
All right, and wait, just to show everyone, a singular stone left, and it is Varad's turn. So Varad has won the game. Let's give it up for Varad, everybody. Well done.
Thank you.
Great. Now, this is, I'll get into the frame, but this is a math society, not a game society, right? So should we get into the maths of it?
Absolutely. So, thank you. Good game. Good game. I respect your effort. Thank you for coming up. But what happened there was not just magic. No, it was what's called as combinatorial game theory. So now I'll get into a little bit more about this.
Should we do the demo here? Or?
We'll play the demo at the end and see
Okay,
if the
yeah,
audience will, by the end of this, figure out how to win
All right.
all the time in NIM. So, firstly, you might be wondering, what is combinatorial game theory? So, this is a framework which allows you to analyze each game with a certain set of characteristics. So, for example, each game must have 2 players, it must have alternating moves with perfect information and no randomness whatsoever. This differs from something like economical game theory, which I'm sure many of you would have heard of, which chance is most certainly an element. So something like poker, for example, where your cards aren't, you don't know your cards until you get them. So this removes the entire element of probability, and what remains here is pure structure. The key idea in combinatorial game theory is that all the information is laid out from the start. So the game is finished before you even know it, basically, considering that all players play with perfect play. So positions are...
Shall we go to the next one? Yeah.
Oh.
Oh, that's a great point, actually. So what happens here? I'll explain some of the maths behind what happened in our game.
Okay.
So each pile can be represented as a binary vector. So if you rewrite how many stones are in each pile that we had in terms of binary, what we can do is take the I believe it's exclusive or.
Exclusively. For those of us who take computer science.
You may have heard of that. I don't take computer science, so I wouldn't know about that. But
exclusively or. Yeah.
And you take the sum, or the NIM sum is what it's called. I believe it's just binary addition, but you don't carry anything.
Yeah, exactly.
So by the end of this, you'll get a value, right? And your whole objective is to try and make your NIM sum equal to 0. If their NIM sum is equal to 0, that means that they have no winning moves in that position. Hence, you can always win in any position as long as their NIM sum is 0. Likewise, if your NIM sum is 0, then you have no winning moves, and considering if they play perfectly, you have no chance of winning. And what combinatorial game theory states, you can...
Oh, just one thing before we go to the next slide. So what Varad just described there is called Bouton's theorem. A NIM position is a P position if and only the NIM sum of the piles is 0. So
and if you P position means that the previous player wins.
Yeah.
So, NIM is basically the framework for all impartial games when it comes to combinatorial game theory. So every other game, which is an impartial game, can be transferred into a version of NIM. What that means is you can represent everything as binary vectors, everything in terms of a specific position of NIM, which will enable you to win basically every impartial game. So impartial games are basically the simpler subsection of combinatorial game theory. Why it works is basically from a 0 NIM sum position, every move will create a NIM sum position. Well, every move will create a non-zero NIM sum. And if it's non-zero in your position, then you're winning, because you'll always be able to revert it back to 0. And if a position is forced, then obviously you're not going to be able to make 0, which leads you to losing, basically. Think of it, if any of you are like into chess, if you've heard of a Zugzwang, it's where you have a forced position and you're not able to play anything good. It's basically similar to that. So yeah, move on to...
let's go into the next slide. And we've just got a small formula here if you just want to talk them through that.
I'll be honest, I'm not
familiar
with this
formula. So this formula, can everyone see the formula up here? This might be a bit small, but you can read it. Now, essentially, this formula boils down the game of NIM, any impartial game, like he was talking to just a bunch of simple maths. Now, this includes chess, I believe, right? as chess is an impartial game.
Chess is not an impartial game, but we'll get onto that.
Yeah, but
We'll get onto that.
we'll get onto it. So if anyone would likes to look into the maths here, we've got it on our presentation website. We'll be distributing you this website later, so you can take a look at this sort of interactive demo.
So, as you may be aware,
Is the right
sorry,
slide?
yeah, I'm not sure it is, but it's fine.
Oh, okay.
So, obviously, not every game is an impartial game. Many games are not impartial games, such as checkers, because you're not operating on the same premise. I think about Nim, we're both working on the same stones. but for something like chess or checkers, you each have different moves. Like I control the black or white pieces, whereas my opponent controls the other color pieces. So that makes it what's called as a partisan game. And partisan games are a lot more complicated than impartial games. So to analyze these, we define everything, or we define positions recursively, as G is a set of left and right moves.
Oh, sorry.
Is this?
Yeah, there you go.
Okay. So L is all of the positions that left can move to, and R is all of the positions that right can move to. And basically, an entire new framework of numbers has been created through combinatorial game theory called Surreal numbers, which was developed by John Conway. And this basically is defined arithmetic in the sense that 0 is, well, there's nothing in the set.
Yeah.
1 is 0 on the left.
Yeah.
Oh, sorry.
So day 0 is 0 in the surreal number set. Then you get day 1. Yep.
Yeah. Sorry, I thought you were walking through it. Yeah.
And then day 2.
Then day 2 is. No, I'll be fully honest. I'm not sure what the days are for.
No, so the days just essentially represent each move, right? It is slightly abstract the way that we've laid it out, but for us, learning isn't just about us telling you all the answers, right? We've put a couple of Easter eggs in the presentation website so that when you guys go home, you can sort of delve into it a little more.
And like, what's crazy about this is like using this new like the surreal number system.
Yeah.
You're able to like compare and contrast different games. So like you're able to classify everything as a certain game. You're able to add games, subtract games. I'll be honest, it's very abstract. It's a very abstract idea to what I'm familiar with, but it's a pretty interesting thing that I would definitely consider researching if you have more time.
Yeah.
Next slide.
Next slide. Yeah, there you
go. So what are the applications of combinatorial game theory? So, if you know games such as chess, well, chess actually less so, but checkers has been solved due to CGT.
Mm-hmm. CGT stands for Combinatorial Game Theory, for those of us who might not know.
Cheers. By classifying positions such as wins, losses, or draws in any given position. And it also provides, well, more concrete models for things like recursion, induction, and algebraic structure.
Yeah.
It's also heavily used in like the development of AI, which is
that's the reason we had so much AI generated promotional content. It was sort of a Easter egg into the PowerPoint.
From the start, it was us leading to
four-dimensional thinking. You just need to know.
Thank you. Welcome. Take a seat.
Feel free to take a seat.
You can take a front
row
seat if you'd like.
Guys, sorry. Let's continue with the presentation, shall we?
So ultimately, it's been used in the development of many things.
So sorry. Let's just pause a second. Let's just let our new guest take a seat. Yeah. All right. So guys, let's keep going with the presentation, please.
Yeah. The next slide. Yeah.
Is that the last one? That's it, bro.
Yeah, that's fine. Okay. So if you're interested in this kind of thing, I'd recommend reading "Winning Ways for Your Mathematical Plays." It's a book.
Who's the book?
I'm not entirely sure. I do have it on here.
Yeah.
But you can search that up. It's I'm sure it's a very interesting book.
Yeah.
So to finish things off, I'd like the audience now using
Guys, sorry, can we
using
put our
what-
attention back on?
using what I've talked about NimSums.
Yeah.
I'd like you to bring back the online NimSum game.
Yeah.
And we're going to win against the computer with
Yeah.
perfect play, okay?
Are we?
Yeah, we are.
You sure?
Yeah, we are.
Alright.
Okay.
yo, we better win, yeah.
No.
Sorry.
When I
one-
say we, I mean the audience.
Yeah.
By the way.
One question at the back, yeah. A definition of a game. Look, for me, the way I live my life, it isn't the most sort of arithmetical sort of linear way, right? I'm a very spiritual person. So for me, the definition of a game is something that you do that gives you enjoyment that you can play with someone else. Yeah. Yeah. It's yeah.
Well, it's very close. It's like one of the closest to being an impartial game, but I don't believe it is.
But the thing is, because with tic-tac-toe,
no. I believe so.
Yeah, it's a partisan game. Yeah.
Yeah, go on.
Sorry. Guys, I think there's a bit of chatter coming from here. Can we just lower it down?
So-
yeah. Sorry, one sec.
I was gonna finish his question off because in tic-tac-toe you each control different square like noughts and crosses,
Yeah.
right? If I'm controlling the crosses and someone else is controlling the noughts, we're not controlling the same thing.
Yeah.
It's not part of the same framework, basically. That's why it's passed.
So I think we had a question from Prairie.
How can CGT play chess? Because at the moment,
Yeah.
chess is not on fire.
Yeah.
Really fire.
Yeah.
Who's bad? Okay. Anyway, yeah. Do you wanna answer that?
So you gonna let me answer his question or?
Guys, sorry. Prairie asked a very good question, so let's wait for the reply. Yeah.
So look, using CGT only really affects like the best of the best, right? Like for example, I believe Stockfish uses some form of CGT. I assume you know what Stockfish is.
Yeah. Stockfish is a very good computational chess model.
Does it trade stocks?
It does not.
Look,
Sorry.
Stocks is a game, but it's a different kind of game. It's a game of life.
So as I was saying, those high-end frameworks are gonna, go over the top, increase due to CGT, but your average person won't really be benefiting from CGT because at the end of the day, you're not going to be like operating on that high of like a
Respectfully.
like obviously I'm saying that for anyone. Like this is something we're talking about like computers that are doing this kind of section.
But let's say you did use CGT to solve checkers or something. How exactly do you go by solving checkers? How long would that sort of algorithm take? I'd imagine it'd be years.
Yeah, I believe
Exactly,
it was years for checkers to become solved. It remained unsolved for a very long time.
Yeah.
I believe decades actually.
Yeah, because if you take a look later on, we were talking about the surreal numbers line. Guys, sorry, Saksham asked the question. So if you look at the surreal numbers line, it's like it increases with each possible combination and permutation of the game, right? To take something like checkers, there's like, Googles of potential moves and things like that you can do, or that you can do at any specific time. So because of that, computationally, it's obviously more difficult than something like Nim.
Following on from that, also checkers it's not new to the business. It's been around the block for a while. So obviously, to think about the fact that CGT has been developed like 1960s, the surreal number system.
Yeah.
And since it's a partisan game, I assume it would have been several thousands of years before it actually became solved.
Amok. Yeah.
What's the definition of combinatorial?
That's a great question.
You guys know who Ramanujan is, right? If you guys watch the Ramanujan movie, it will give you a bit more insight into that. Yeah. All right. Sorry? Look, this is meant to serve as an entry point into combinatorial game theory, right?
It's a good question that we don't have an answer to.
Look, Amog, look. Learning, it's a vast art, right? I can't give you all the answers.
That's your job to figure out.
Again, going back, this is meant to serve as an entry point into CGT. Yeah. Dev Patel. Yeah. All right, does anyone else have a... Yeah, Afrin, do you have a question? Sorry. No.
So obviously, as stated, combinatorial game theory does rely on literally you need perfect information, and like for Fortnite, right, you have like loot boxes. You're not always gonna know what's inside those loot. Like I'm putting it into context, right? You're not always gonna know what's inside those loot boxes. So it's like you're not. This wouldn't apply. I assume something like economic game theory would apply, but not combinatorial.
Are we gonna do the computer?
That I'm not aware of.
We're gonna do the computer game.
Yeah. Let's finish.
All
off
right,
with the
guys.
computer game.
Okay, so we're gonna do computer versus the audience to round off this game of Nim. So we're gonna go first. What should our first move be, guys? Anyone got any ideas? Arush wants a rematch. All right, Arush. Okay, come on. Let's get Arush to come up.
Tell you what.
All right, so wait, let's just let Arush.
Let's get Arush.
Okay, Arush, come to the computer. All right, so for those of us watching online, here's our challenger, Arush. He lost earlier in the session, and he thinks that he'll be able to win against the computer. Yeah. Wait, I'll come in.
We're gonna take a whole pile away.
Okay.
If there's an even number of piles, we're gonna reduce one of the piles to 1. Basically.
Interesting. All right. Okay, so
it gives you the nim sum.
So what you can do, right, is you hover over it. The yellow ones, how many? That's how many you take away. Huh? What is your?
You don't answer such questions.
Did you code this?
What is code? As in what? Okay, yeah. Guys, let's let Arush. Love. I don't. What is love? Love. I live life with love, but I don't know what lovable is. Okay. So look. Okay. So Arush took the whole of the 3 pile. The computer's taken 2 off the one with 7.
Guys, can we apply any principles to this? The nim sum is 0. What have we learned?
He's lost.
He's lost.
Yeah, he's lost the game already.
He's already lost. I thought the computer has perfect play.
Game is gone.
Oh, Arush,
That's unlucky.
the man who thought he could beat the computer, has failed the combinatorial game.
Guys, give it up for Arush.
Give it up for Arush Mukherjee, everyone. Yeah, all right. Does anyone have any more questions, queries, and concerns related to CGT? Sorry, what? Huh? Was that for us or was that for him? Yes, Akshaiyan, did you have a question? Okay. All right. Anyone else got any other thoughts on the presentation in general?
Right, guys, we're going to wrap it up there. Thank you so much.
Thank you so much.
I love you all, yeah? Thank you.
Wait, before you stop the recording, guys, I just want to finish our lovely presentation off with a quote. If you want to make the world a better place, take a look at the maths and make a change. Thank you very much, everyone.